Okie dokie. In this video, we're knocking out WebAssign 2.7, starting with number 1. Determine whether this function is a polynomial, rational, or some other function. So I'll go ahead and say a rational function is one that's set up as a ratio, as a quotient. Typically, a rational number is something in the form of a over b. So a rational function is basically, some function over some other function. Basically just like, if you see a quotient. The biggest thing probably is having x terms on top and bottom. Because if you just have them on top and you just have constants on the bottom, then there's a chance that could just be a polynomial. Now, a polynomial is just something of the form like ax to some power plus bx to some power minus 1, and then plus cx to some other power. The biggest thing is that you can't have non-negative exponents, and you can't have fraction or like decimal exponents. You can only have whole number, integer, positive exponents for the x terms here. So, we'll see examples as we go through. So in this case, we have x's on top and bottom. I'm thinking rational for this one. And so if it's not polynomial, we just say DNE. For the degree refers to the highest x exponent of a polynomial. So like in this case, if this was expanded out, this would definitely have the form of like 3x to some power n, minus something to x to some other power. Basically the idea is it would just be a bunch of x terms to different powers. Now, what we do need to figure out is the degree, like what the highest exponent would be once we expanded it out. So I'm going to go ahead and say this is a polynomial. It's not going to be rational. There's no quotient. It's not going to be any other function. So the degree is basically what we would get for the highest exponent if we did expand this out. So you'd have to think about x cubed to the fourth. So x cubed to the fourth, we've talked about before with exponent rules. We multiply those exponents, so we get x to the 12th. And then, the whole term itself would be 3x to the 12th. And then from there, there's probably some, plus something x to the 9th, or x to the 6th, or whatever from there. So that's why it's polynomial. So 12 is our degree, just the highest exponent you'd get from those terms. Now, in this case, it kind of looks as though it's a polynomial, right? It's just like x to certain exponents. But the issue here is we have negative exponents. And so is it rational? I don't know. It doesn't look like a quotient. So would it be? Well, I think in this case, they're considering it as, what if we rewrote each of these terms so that they had positive exponents? And then technically, if you rewrote this a certain way, you could end up writing all of this as one big fraction if you got one common denominator, right? You could have, 8 plus 4x squared plus 9x to the fifth, and that would all be over x to the fifth if you wanted to do that. So, this is equivalent to that, and that, this down here is a rational function. So basically, I would say just like once you see negative exponents, it's not polynomial. And I don't know if the answer is ever going to be other. I don't know if you even need to look for that. But yeah, so you could almost just assume if it's not polynomial, it might just be rational for those. Number 4.
Would you like to finish your homework so you can get your degree? Go to payhip.com/VTMathTutor.
Bye.